Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you the formal definition of limit. So if you can make the values of fx, so fx here is the function which depends on x. Well, the value of fx here is to be made arbitrarily close to L. So the meaning of arbitrarily close is, in a simple words, you can say that we want the values of x to be as close to L as you like, or as close to L as you wish. Well, in this case, obviously there is no specific rule. It is entirely up to you to make it as close to L. So in order to do that, you can take x to be sufficiently close to A but not equal to A. So the process here gives us the following mathematical result. Okay, we can write down the whole process here with this mathematical representation, where basically if you want, you are actually saying that this mathematical statement here is equal to saying the limiting values of our function here as x approaches A is equal to L. So notice that here we have a phrase but not equal to A, which means that in the process of doing this, we will never consider x equals to A. We are just concerned with finding the limit of our function here fx as x approaches A, but never consider x equals to A. Okay, so the consequence is that there will be some circumstances when you will see that sometimes fx here is not defined when you plug in the value of x equals to A inside the function, but it is not going to cause you any problem. It is still okay and the limit still exists even though the function here is not defined. So what does it mean when I say the function is not defined? In simple words, basically when you plug in the values of x equals to A into this function will be unable to compute. Okay, right, so now these are the graphic representation to describe or to explain the definition of limit. Okay, so in this case, if you see that limit is all about making x approaches A, so x can approach this value A either in this direction or from the left direction. Okay, so when x approaches A from the right direction, you will see that the value of y here will go in this way and it will come and approach the value of L. Similarly, if x approaches A from this direction, from the left direction, then you can see that our value of y here is going upwards and it will come and get very close to L. So what we can see here is that the limit of our function fx when x approaches A is equal to L. So based on this graph here, this is what you can say. So this is the first scenario. Now the second scenario is that again, when x approaches A in this direction, you will see that the value of y will be getting closer and closer to L. And then if x approaches A from this direction, the value of y is also going upwards and it will come to be very close to L here. Now notice that at this point there is the round circle, there is this open circle, where it basically means that the value of a, if you plug in the value of a into our function, the result is not going to be equal to L because there is this open circle here. Whereas the result of a when a is plugged into the function is going to be at this point here. So that is the point of, that is the value for fa. So in this case, the limit still exists. So limit still exists, which is equal to L. But if you plug in the value of a into the function, the result is not going to be equal to L. It is defined, but it is somewhere else. Okay, so that is the second scenario. Now the third scenario that we have here is when you see x approaches a from the right direction, you can see that the value of y is going to be getting closer and closer to L. Similarly, when x approaches a in the left direction, then y is going upwards and will come to a point close to L, right? So therefore, we can say that in this case, limit x approaches a for this function is going to be equal to L. But if you look at this graph carefully, there is this open circle here, which indicates that if you plug in the value of a into our function, then the result here is going to be undefined because there is no value of fa. So fa in this case is undefined. There is no point for fa. So I hope you can differentiate the two cases here. So in this case here, fa is undefined. In this one, fa is defined, but it is somewhere else. It is not equal to the value of L given here. Okay. So just to conclude, all these three cases demonstrate that the limit exists, but you can come into a scenario where this is undefined. This is defined, but somewhere else the point is not equal to L. This is defined where if you substitute a into the function, so if you substitute a into the function, you will get the answer is still equal to L. So we have three different cases here, but all these cases give you the same definition, give you the same story, which is to say that the limit of this function still exists. Okay. Right, now let's look at a concrete example of finding the limiting value of this given function here. So I hope you can see that this is the case where you are interested to find what happens when x approaches 1. So I hope you can see that when x is equal to 1, the function will be undefined. This is because if you substitute 1 into this function, you will get 1 minus 1 over 1 minus 1. So here we have 0 over 0, and that is going to cause you a problem in computing the result. Okay, so there you go. X equals to 1 will make the function undefined, but it doesn't matter because based on the table which I have constructed here, you can see that the value of x gets closer and closer to 1, but never actually we consider x equals to 1. So for this table here, the value of x comes from the left direction. So you can see that if this is the value of x equals to 1, now for this one we consider the value for x being less than 1. So x is coming to 1 from this direction. Okay. For this table here, the value of x considered here is greater than 1, which means that the value of x here is getting closer and closer to 1, but never actually we consider x equals to 1. So these values here comes on the right direction, so they are approaching x equals to 1 from the right direction. Yep. Okay, so right. Well, we can start off, okay, with saying x equals to 0.5. So when x is equal to 0.5, then the function that we have here is going to be equal to 0.5 minus 1 over 0.25 minus 1. So this will give you the result of positive 0.666667. So try to retain as many decimal points as possible. I think 6 decimal points is enough. So that is for x 0.5. Now if you consider x equals to 1.5, so x is equal to 1.5, therefore my fx is going to be equal to 1.5 minus 1, 1.5 squared minus 1, and the result is going to be equal to 0.4. Okay, so you can go on and complete the whole table, and the results that you will get are given as such. So based on this result here, we're going to just focus at the end of it, where you can see that the pattern of the values here approach a certain number, and in this case we can guess the value of limit x approaches 1 for our function is going to be about 0.5. So what we can write now, therefore based on the result here, the limit of our function, limiting value of our function as x approaches 1 is going to be equal to 0.5. Alright, I think that's all for now. Thank you very much for watching.